Good day everyone, I am Jabo Farhana and I will be discussing what is titration. My objective is to explain how to carry out on acid-base titration and to describe how an acid-base indicator function. And these are the types of titrations, which is the acid-base titrations, and the second one is redox titrations, precipitation titrations, and the last one is complexometric titrations. So the first one is acid-base titration is an experimental procedure used to determine the unknown concentration of an acid or base by precisely neutralizing it with an acid or base of known concentration. This lets us quantitatively analyze the concentration of the unknown solution. The next one is redox titration, is a titration in which the analyte and titrant react through oxidation reduction reaction. As in acid-base titrations, the endpoint of a redox titration is often detected using an indicator. Precipitation titration is a type of titration which involves the formation of precipitate during the titration technique. In precipitation titration, the titrant reacts with analyte and forms an insoluble substance called precipitate. It continues till the last amount of analyte is consumed. And the last one is complexometric titration, is a form of volumetric analysis in which the formation of a colored complex is used to indicate the endpoint of a titrational.
Titration is a technique used to work out the concentration of an unknown solution when you know the concentration of another solution. You carefully add the known solution to a set volume of the unknown solution until the reaction is complete. This enables you to work out the concentration of the unknown solution. You may need to use the indicator to signal the end of the reaction. You can calculate the concentration of an acid or an alkali by carrying out a titration experiment. In this video, we're going to look at how to carry out titrations. In the next video, we will then look at the calculations to go with the experiment. The apparatus needed for titrations looks like this. The pipette is needed to accurately measure a certain volume of the unknown solution into the flask. The burette is then used to accurately measure and add the known reactant to the unknown until the reaction is complete. The burette can measure up to 0.05 cubic centimeters accuracy. To carry out a titration, you follow these steps. 1. Using the pipette, add a set volume of the unknown solution to a clean conical flask. 2. You may also need to add a few drops of indicator. 3. Fill the burette with a known solution. 4. Record the starting volume on the burette. 5. Slowly add the solution from the burette to the unknown solution in the conical flask. You may need to swirl the flask to mix, or use a stir plate. 7. Stop adding when the reaction is complete. The endpoint is reached. This is where an indicator may help because there would be an appropriate color change. 8. Record the final volume. 9. Subtract the final volume from the initial reading. This gives you the volume of the solution added. This volume is called the titra. 10. For an accurate experiment, you should repeat this experiment a few times until you get consistent values for the titra. Depending what indicator you use will depend if the color change is gradual or a sudden change. If you are carrying out an acid-alkali titration, you may use a universal indicator which would give you gradual color change, whereas litmus would give you a sudden color change. Sometimes the acid may be the known solution and the alkali unknown, and other times the alkali the known and the acid unknown.
And my conclusion is in the process of titration, a basic solution is gradually added to this acidic solution until complete neutralization is obtained. The end point of the titration is detected with the help of an indicator as color of the solution changes upon neutralization.